Hey again, everybody. Here is your intro to the Maclaurin series for Sine X. So we're looking for a Maclaurin series representation for Sine X. And again, my Maclaurin series generically looks like this. Again, since it's Maclaurin, I'm centering it at 0. So I'm using 0 for my a value. That's why I don't have x minus a to the n. A is 0. And in order to do this, again, we're going to set up our chart. If you saw the e to the x video, or you were in class, you saw this already. But it can't hurt to see it again. So here's my n terms, my counters, my nth derivative not evaluated of x, my nth derivative evaluated at 0. And this time, we're not quite as lucky as e to the x. Okay, for e to the x, we just had e to the x's everywhere, and all these numbers were the same. This is a little different. My nth derivative, so my 0th derivative is just sine x. That's basically just saying take your original. My first derivative is cosine. My second derivative would be negative sine, then negative cosine, then positive sine, and back we go. Okay? If I plug in 0 here, I get 0. Well, that's not very exciting. If I plug in 0 here, I get 1. Okay, I can work with that. Then this is another 0, but then negative 1, and then 0. And then positive 1. And if you do enough of them, you start to see the pattern. These terms here, if you skip one, every other term is 0. So those aren't really going to help me with my representation. But this is going to help, and this is going to help, and this is going to help. The only thing is they alternate signs. We've seen that before. So my sine x is going to be a series that alternates in sign, starting with positive and then going negative. So starting with positive would be just to the n power. And then I have a 1 here. I'm sorry, a 1 here. So I have my first term. Actually, you know what? It might be easier. Let me list out some of these terms first. Maybe we'll see it better there. So my first term is going to be 1, x to the 1 over 1 factorial. Okay, I'm doing each of these pieces separately. Okay, oops. No, thank you. Do not want to do that. So here's the 1 right there. The nth derivative at 0 is 1. My x to the 1 is right here, and then my n factorial is here, which is an unbelievably fancy way of writing the number or the letter x, right? Because this is basically 1x to the 1 over 1. Not too exciting, but that's my first term. My next term here, I'm going to skip the 0, and I'm going to jump right to here when n is 3. When n is 3, I'm negative 1 x to the 3 over 3 factorial, right? If n is 3, because this is where my next term is, well, then my n is 3 here and my n is 3 here. And where did then minus 1 come from? Well, that came from this part. Next would be plus, right? Skip the n to the n equaling 4. N equaling 5, I get a positive 1 x to the 5 over 5 factorial. And without even doing any more chart, I could probably figure out what the next term is going to be. Went plus, minus, 1, x to the 1, x to the 3, x to the 5, x to the 7, 1 factorial, 3 factorial, 5 factorial, and 7 factorial, etc., etc. So there's my first 4 terms, my first 4 non-zero terms for sine x. Well, let's try to come up with a formula for that. I already did the alternating part. That was kind of easy, but it might have been hard to know what's coming next because you might not have realized that we have to only use odd powers. So it's still x to something, but it's not x to the n. It's not x to the n plus 1. It's x to the 2n plus 1. That's the only way to guarantee odd numbers starting at 1. Okay? Divided by all the same odd numbers, but factorial. Okay, if you're not sure, and if you do, maybe you just wrote 2n plus 2 or something. I don't know. Put in n equals 0 and see what you get. Put in n equals 1 and see what you get. You should get these same terms one by one. This is the Maclaurin series for sine x. This is another one of the core 4. Okay, so e to the x, sine x, cosine x is going to be next, and then the geometric series, which will be the last one. Okay, although we really did that one first. So this is your core 4 for sine. Now a question they could easily ask would be, find a Maclaurin series for sine of 4x. Okay, find the Maclaurin series for sine of 4x. All right, no problem. I know already the sine of x is this series, negative 1 to the n, x to the 2n plus 1. But if you want me to do 4x instead, well, guess what? I'm going to do 4x to the 2n plus 1 over 2n plus 1 factorial. And there's your sine of 4x. Okay, so that's what we need to be able to do, little things like that. Now, worst case scenario, you could generate this. You could, if you want, you know what, let's do it. Why not? What the heck? Let's generate that. Okay, so let me just copy it down real quick. I want sine of 4x. Let's pretend we don't remember our core 4, you know, for one of our core Maclaurin series for sine x. So we go back to the drawing board. Okay, so here's sine 4x, and the question is Maclaurin. Okay, can we find the Maclaurin series for that? Well, first of all, we know the generic series looks like this. Right? We're going to start every Maclaurin series like that, but as I did before, our focus will be on finding those terms. So we'll set up a chart. N, Fn of x, Fn of 0. Let's see how many we need before we figure out a pattern here. My original is sine of 4x. So my first derivative is 4 cosine of 4x, right? I got a chain rule kicker. And then I've got negative 4 squared sine 4x. And then I've got a negative 4 cubed cosine 4x. Then a positive 4 to the 4th, the sine of 4x. Sorry, I'm thinking ahead. Okay, so I still have my sine, cosine, negative cosine, and then positive sine. But I have all these 4's coming out as chain rule kickers. Okay, so Fn of 0, if I plug in 0, well, that's still 0. Plug in 0 here, that's going to be 4. This is going to be negative 4 squared, not in parentheses. I'm sorry, that's a 0. I'm so sorry. I got excited because I saw something different. Okay, so plug in 0, you get 0. Plug in 0 here, you get 1 times 4. Plug in 0 here, you get 0. 0 here, you get 1 times negative 4 cubed. And then plug in 0 here, you get 0. And then if I did one more, let's just do one more. 4 to the 5th cosine 4x. If I plug in 0 here, I get 1 times 4 to the 5th, positive. So hopefully you can see the pattern. It still alternates. Okay, so I'm expecting, oh my gosh, look at that one. So I'm expecting an alternating series, which makes sense. But I'm not going to, I have all these 4's now instead of 1's. So it's going to be 4 to the n, right? It's a perfect match. N is 1, n is 3, n is 5. So, but they're odd, but they're odds, right? 1, 3, 5. So 4 to the 2n plus 1. And then I have x to the 2n plus 1 over 2n plus 1 factorial. And if I rewrite that, n equals 0 to infinity. This is 4x to the 2n plus 1 over 2n plus 1 factorial. Okay, and if you're wondering where these came from, it's the same thing as before, right? When we did it before over here. If I were to list out all these terms, they'd be exactly the same. The only difference is I'd have 4's coming along for the ride instead of 1's. Okay, that's why I just sort of shortcutted that a little bit. But that worked. And then, you know what, to be honest, if you left it like this, it would still work. But I don't know, I guess it depends. If there's other terms that have to be combined, sometimes they'll pull these out. But this would be the Maclaurin series for sine of 4x. Okay, so that should cover sine x for you, hopefully. If you have any questions on that one, please let me know, and I will definitely talk to you guys later.